There's a deeply seductive idea that has captured the imagination of engineers, billionaires, and dreamers across the last several decades. The idea goes something like this: Mars is cold, barren, and airless. But those are merely engineering problems. Build a thick enough wall, pressurize the interior, grow some food, recycle some water, and the red planet becomes humanity's second home. It sounds reasonable, it sounds achievable, and it is, at its foundation, one of the most catastrophically naive assumptions ever dressed up in the language of science. The universe is not a passive backdrop against which human beings get to construct their ambitions. The universe is an active, violent, extraordinarily energetic system, and the particles it launches across galactic distances do not negotiate with metal walls. To understand why Mars represents not merely a logistical challenge but a near absolute physical barrier, you have to stop thinking about space as a vacuum and start thinking about it as an ocean. Not an ocean of water, but an ocean of atomic nuclei moving at velocities that border on the speed of light itself. These are galactic cosmic rays. And they are not the kind of radiation that a lead apron at your dentist's office was designed to stop. To appreciate what we are truly confronting, consider an analogy. Imagine you are standing behind a wall constructed entirely of extremely fragile, highly pressurized glass. On the other side of that wall, someone is firing high-speed military rounds, not small-caliber ammunition, but heavy, dense projectiles moving with enormous kinetic energy. Your instinct tells you the wall will protect you, but here is the physical reality. When one of those heavy rounds strikes the glass, the wall does not absorb the kinetic energy and stop the threat. The wall shatters violently. That single incoming round transforms itself into thousands of razor-sharp glass fragments moving in every direction simultaneously. The protective structure you believed would save your life has physically amplified the threat. One localized strike has become a devastating, dispersed shotgun blast directed precisely at your body. That is not a metaphor loosely borrowed from physics. That is the precise subatomic mechanism that governs what happens when galactic cosmic rays encounter a dense metallic wall. The phenomenon has a name. It is called spallation. And it is the reason that conventional physical shielding does not solve the Mars radiation problem. It fundamentally makes the problem worse. Here is the particle physics at the core of this nightmare. Galactic cosmic rays are not photons. They are not electromagnetic waves that can be absorbed by a sufficiently thick slab of material the way ordinary light is absorbed by a curtain. Galactic cosmic rays are atomic nuclei. They are the stripped cores of atoms, protons, helium nuclei, and nuclei of far heavier elements, iron, silicon, magnesium, accelerated by the catastrophic shock waves of distant supernovae to velocities exceeding 99% of the speed of light. These particles carry kinetic energies so enormous that no purely physical mass we could reasonably construct around a human habitat would bring them to rest. They are not stopped by matter. They interact with matter at the subatomic level, and those interactions produce consequences that are catastrophically worse than the original particle event. When a high-energy iron nucleus traveling at near light speed strikes a dense metallic hull, the kinetic energy of that collision is sufficient to disintegrate the nuclei of the metal atoms themselves. The incoming cosmic ray shatters the iron or aluminum of your habitat wall. In doing so, it spawns a cascade of secondary particles, fast neutrons, protons, lighter nuclear fragments, and a spray of pions that immediately begin decaying into further secondary radiation. The interior of your carefully constructed habitat is not shielded by the wall, it is flooded by the wall. The biological tissue on the other side, your neurons, your bone marrow, the spiral ladder of DNA coiled inside every one of your cells, now faces not one high-energy particle, but hundreds of secondary particles, each carrying enough energy to ionize molecules, sever chemical bonds, and initiate cascades of biological damage that accumulate with every passing hour. Adding more metal to the wall does not solve this. Adding more metal to the wall provides more material for spallation to operate on, more atomic nuclei to shatter, more secondary particles to flood the interior. There is a point in the shielding thickness curve where additional material begins to increase the biological radiation dose rather than decrease it. Physics has closed the door on the naive engineering solution before that engineering solution ever reached the drawing board. Now ask a deeper question. Why does none of this happen on Earth? The answer lives roughly 1,800 miles beneath your feet. Earth's outer core is an ocean of liquid iron and nickel, a mass of churning, electrically conductive fluid at temperatures exceeding 4,000 degrees Celsius. This liquid iron rotates, and because it is electrically conductive and rotating, it behaves as a natural dynamo, generating a magnetic field of extraordinary scale and complexity. The field extends tens of thousands of kilometers into space in all directions, forming what physicists call the magnetosphere, an enormous invisible envelope of magnetic force that encloses the entire planet. This magnetosphere is the physical mechanism that makes biological life possible on Earth. When a galactic cosmic ray approaches the planet, it is a charged particle, and charged particles moving through a magnetic field do not travel in straight lines. They curve. The magnetic force deflects them, bends their trajectories, and redirects them away from the surface or funnels them harmlessly into the polar regions where they produce auroras. The radiation that reaches Earth's surface is a tiny fraction of what bathes the surrounding space. Every cell in your body at this moment is being protected not by a wall, but by a magnetic force field generated by billions of tons of liquid iron spinning deep inside a planet. Mars has no such mechanism. Mars is, from the perspective of planetary geophysics, a dead world. Its small size meant that it cooled far more rapidly than Earth. When the internal heat dissipated, the liquid iron that once churned inside its core solidified. The dynamo shut down. The magnetic field collapsed. Geological evidence preserved in Martian rocks tells us that Mars once possessed a magnetic field, billions of years ago, but it died when the planet's interior froze. Today, the Martian surface is exposed directly to the solar wind and to the full intensity of galactic cosmic ray bombardment with essentially zero magnetic protection. This is not a problem that an engineering team on a budget can solve. Generating a planetary magnetic field requires either restarting the internal dynamo of an entire planet or constructing an artificial magnetic shield of such enormous scale that the energy requirements place it comfortably beyond anything our civilization currently produces. Proposals for an artificial magnetic shield have been explored theoretically, involving enormous superconducting loops positioned at the Mars L1 Lagrange point. But these remain purely theoretical and demand infrastructure that would require decades of development and essentially unlimited energy sources, so the colony sits on the unshielded surface. And the spallation problem means the walls of the colony make the radiation inside worse. What does this mean for the biology inside? Chronic exposure to the secondary radiation cascade inside a spallation-rich habitat attacks biology at its most fundamental computational level. DNA is not a robust molecule. It is a sequence of chemical bonds, and ionizing radiation severs those bonds with precision. The biological repair machinery inside cells can handle a limited rate of damage, but in a chronic high-dose environment, the rate of damage exceeds the rate of repair. The result is not a dramatic, immediate death. It is a slow, systematic degradation of genetic fidelity. Cells accumulate mutations. Oncogenic pathways activate. The immune system, itself composed of radiosensitive cells, begins to fail. Cognitive function erodes as neuronal DNA accumulates unrepaired damage over months and years. And then the thermodynamics begin to work on the mechanical systems keeping the occupants alive. A closed biological system like a pressurized Mars habitat is not a stable equilibrium. It is a fragile, enormously ordered structure held in place by thousands of interconnected mechanical and electronic subsystems. Pumps circulating atmospheric gases, sensors monitoring carbon dioxide levels, electrolysis systems splitting water into breathable oxygen, filtration membranes removing biological waste, thermal regulation systems preventing the interior from swinging to the negative 60 degrees Celsius ambient temperature of the Martian surface. Each of these systems is a precisely ordered mechanical structure. And the second law of thermodynamics dictates with absolute physical certainty that ordered systems degrade toward disorder in the absence of continuous energy input. Now subject all of those systems to a continuous secondary radiation shower generated by spallation inside the habitat walls. Electronic sensors are disrupted by ionizing radiation. Semiconductor components accumulate radiation damage over time, developing what engineers call single-event upsets, bit flips in digital systems caused by particle strikes passing through circuit elements. Polymer seals and gaskets degrade as radiation breaks the long chain molecules that give them their elasticity. Membrane filters suffer structural damage at the molecular level. Each of these degradation pathways is individually manageable for a short mission. Across years and decades of continuous colonization, the maintenance burden compounds relentlessly, and every repair operation requires human beings to work in an environment that is simultaneously irradiating their own biological tissue. The thermodynamic cost of maintaining biological order inside an irradiated, mechanically degrading enclosure on a magnetically dead world does not plateau. It accelerates. The more the systems degrade, the more they must be repaired. The more time colonists spend repairing systems, the more radiation dose they accumulate. The more radiation dose they accumulate, the more their cognitive and physical capacity to perform repairs diminishes. The physics describes a feedback loop with a negative biological outcome. What the universe is communicating through all of these physical constraints is a precise statement about the conditions under which complex biology can persist. Life does not arise or survive on magnetically dead worlds because the physics of particle interactions with matter ensures that without a planetary magnetic shield, any accumulation of biological complexity will be continuously bombarded, not merely by incoming cosmic rays, but by the secondary cascade that any attempt to build passive physical shelter inevitably produces. Earth is not hospitable to life because it is the right distance from the sun, though that is relevant. Earth is hospitable to life because a liquid iron dynamo billions of tons in mass spins continuously inside it, generating a magnetic force field that deflects the subatomic artillery of the galaxy before it ever contacts the biosphere. Remove that field, and the physics that follows is not merely inconvenient, it is conclusive. Mars does not need better walls. Mars needs a magnetosphere, and the physical requirements for generating one dwarf every engineering achievement in human history by orders of magnitude. The universe has not forbidden Mars with an arbitrary rule. The universe has applied the laws of electromagnetism, particle physics, nuclear spallation mechanics, and thermodynamic entropy simultaneously to the same location, and the combined result of those physical laws operating together produces one clear, mathematically consistent answer. The cosmos reserves the capacity for complex biology not for any world